z is equal to 0, then the value of z inverse will be infinity. So we can define the region of convergence for this x of z as entire the value of entire z plane except z is equal to 0. So this is the ROC for the given problem. First we will find the z transform of right sided sequence. The given problem is find the z transform of x of n, where x of n is equal to 1, 2, 3, 4. Here x of n takes the value only for n is equal to 0, 1, 2, 3, which is nothing but the right side of the vertical axis. That's why we are calling this as a right sided sequence. So first we will write the formula. Here the formula is x of z equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. Here in the common formula, n takes the value minus infinity to plus infinity. If you change the limits of n for this problem, here the starting value of n is equal to 0. Since there is no arrow mark mentioned or dash mentioned, we will consider the starting value belongs to n is equal to 0, followed by the value for n is equal to 1, n is equal to 2, and n is equal to 3. And the useful range of n is nothing but 0 to 3, because for other values of n, x of n takes the value equal to 0. So we will consider only this range, n is equal to 0 to 3, and we will apply the formula. And substituting the values of n, this equation becomes x of 0 z power 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus x of 3 z power minus 3. Here we know the values of x of 0, 1, 2, 3, x of 1, x of 2 and x of 3. Just substitute that value, then you will get 1 into z power 0 plus 2 into z power minus 1 plus 3 into z power minus 2 plus 4 into z power minus 3. Then the final version of x of z is nothing but x of z equal to, here z power 0 is 1, so this can be simplified as 1 plus 2 z inverse plus 3 z power minus 2 plus 4 z power minus 3. Here the important part of the z transform is we have to define the region of convergence, shortly called as ROC. Here ROC is nothing but the values of z for which x of z converges, that is x of z taking finite value only for a particular z values. So in this case we are having a z inverse term. So z inverse term is nothing but 1 by z. Here this z inverse term becomes infinity if z is equal to 0. For all other values of z, this z inverse will take some finite value. So only for z is equal to 0, it will take infinite value.